Hello everyone. So in this video session we are going to study some external treatment methods for water softening. So in previous sessions, we have seen the types of water, what are the types of hardness of water, and if it is permanent hardness of water, then we cannot easily remove it. For that, we need some special chemical treatments. So those special chemical treatments, also called as external treatment methods, we are going to see in the upcoming sessions. So if anyone is there who has not seen my previous sessions, who doesn't know what are the types of water and what are the types of hardness of water, they can refer to my previous video sessions. So in this session, we are going to study about the zeolite method for water softening, which is also called as permutit process. Also, the other methods which we are going to see in next sessions are demineralization process, also called as ion exchange process. Then we are going to see desalination of brackish water. So brackish water is a water which has high content of dissolved salt. So desalination means removal of salt from that water. So there are two membrane techniques which we are going to learn under this. One is electrodialysis and another is reverse osmosis. So let's begin first with the zeolite method. What is zeolite method? How exactly we soften water by using this method externally? Let's have a look. So let's have a look at the structure of zeolite first. So this is the representation of zeolite. So zeolite is basically hydrated sodium aluminosilicate. So this is the structure of zeolite. So in zeolite, it is having aluminium atoms, oxygen atoms, silicon atoms, and water molecules. So these are the water of crystallization. So the framework of zeolite, it has bonds between aluminium, oxygen, and silicon. So it can be either a bond between aluminium, oxygen, aluminium. It can have a framework of silicon, oxygen, silicon, or it can have a framework of aluminium, oxygen, silicon. So the framework of zeolite is three atoms, that is aluminium, oxygen, and silicon, and the sodium atoms are loosely held. So the structure of zeolite you can relate by comparing it to the structure of a honeycomb. So it is similar to the structure of honeycomb. In this, at the framework, at the boundary, you can say the atoms are aluminium, oxygen, and silicon, while in the gaps which are present in the zeolite structure, sodium atoms are loosely held. So they are also called as molecular sieves. So it is having a honeycomb like structure. That means the bonds, the atoms will be present at the corner, while at the gaps, the holes which are present in that, sodium atoms will be loosely held. Sodium cations would be loosely held. So this is the representation of zeolite. So what exactly is going to happen in this process? That the sodium zeolite, we are calling it as sodium zeolite because it is having loosely held sodium atoms, and at the framework of zeolite we are having aluminium, oxygen, and silicon atoms. Also it is having water of crystallization. So it has the property of capturing the heavy metal ions from water and in exchange release the Na plus ions. Since Na plus ions are loosely held, they can easily exchange it with the metal ions or heavy metal ions like calcium or magnesium which are present in water. So the overall result of this process would be that the hard water is converted into soft water, because we know that water is hard due to presence of salts of heavy metal ions like calcium and magnesium. So if we are replacing this ions, heavy metal ions, with light metal ion like sodium ion, then the hard water will get converted into soft water. So this is the principle of zeolite method. So let's have a look at the process. So this is the zeolite method. In this you can see there is a intake for hard water. The hard water will come from this side. Then you can see below in the diagram there is gravel present, that means pebbles or large size stone. Above that there is a layer of coarse sand. Above that, there is a layer of permutit, that means zeolite. And why we have placed these three layers? Because what will happen when the water enters, hard water enters through the top, it will first pass through the gravel. So whatever the larger size impurities are there in water, it will get removed. Then it will pass through coarse sand. So smaller size impurities will also get blocked. And then the water will pass through permitted, because we know permitted is having a honeycomb like structure. That means it was going to have few gaps. So if the larger size impurities are not removed beforehand, it may block the zeolite. So our process of softening of water will not happen. That is why we have a layer of gravel. Above that, we have a layer of coarse sand to remove all the larger size impurities which are present in water. Then the water will pass through zeolite bed or permitted. You can see here all the heavy metal ions present in water, mainly calcium and magnesium, will be replaced with sodium ions. So the water which comes here at the top, which will be a soft water, because in that it will contain equivalent amount of sodium ions. Means if it contains 5, for example, we are just assuming, if water contains 5 magnesium ions, okay, hard water, as it passes through zeolite, after passing to zeolite, here it will contain now 5 sodium ions. The magnesium ions will remain in the zeolite bed, and then soft water can be removed. So water is hard due to presence of soluble salts of heavy metal ions like calcium, magnesium, iron. So those metal ions which are present in the group 2 of periodic table, those are the heavy metal ions. So here the exchange reaction will take place. So let's have a look at the reaction for better understanding. So here we have written Na2Ze. This is our zeolite bed which is having loosely held sodium ions. So when the hard water will pass through the zeolite, the heavy metal ions, magnesium ion, it will be replaced by the sodium ion. So this is the reaction in zeolite. Magnesium will go with the zeolite and Na plus ions will be given out in the water. Same reaction we can do it with calcium also. If calcium is present in water, the calcium ions will take their place in the zeolite bed and sodium ions will be given in the water. So the overall reaction is that our hard water gets converted into soft water. Now there will come a time when all the sodium ions which are present in the zeolite bed are replaced by the magnesium and calcium ions, means the metal ions, heavy metal ions. So at that time we have to regenerate the bed. That means we need to add again the sodium ions in it and remove those heavy metal ions. So for that we use 10% NaCl solution, which is also called as brine solution. So we regenerate the zeolite bed by using a 10% NaCl solution. So this NaCl solution will pass through here and it will go into the zeolite bed again. So it will go into the zeolite bed and the reverse reaction will happen, that Na plus ions will again go into the zeolite and heavy metal ions would be removed and that water would be flushed out. So let's have a look at the regeneration reaction. This is the regeneration reaction. Now our zeolite bed is having the magnesium ion from the hard water sample which we had passed. So we are regenerating it by passing NaCl solution, also called as brine solution. The reaction would be opposite. Na plus ions will take its position in the zeolite bed and MgCl2 will come into the water. So we have to just flush it out. Similarly, we can write the reaction with calcium in the zeolite bed. We are adding NaCl. So Na2 means sodium ions will take their place in the zeolite bed and calcium chloride would be given out. So that water would be simply removed. So this is the process of softening of water by zeolite method. Now there are certain drawbacks of this method also. As you can see that all the metal ions present in hard water are replaced by the sodium ions. So water is getting converted into soft water, but the quantity, the amount of sodium ions is also increasing. Another drawback is that in this zeolite bed in Permutit, we cannot use hot water or we cannot use highly acidic water. So if we use hot water or highly acidic water, then it disrupts the zeolite bed. Another thing is that if water contains salts of heavy metal ions like manganese, which is Mn, or iron, Fe, then this exchange reaction will take place. Means those ions will get captured in the zeolite bed, and in exchange the sodium ions will be released in water. But then the recovery of zeolite bed gets difficult. So that is another drawback. Also, if you see in this method, only the cations are replaced with the sodium ions. The anions which are present in water are not getting replaced. So these drawbacks which are there in the zeolite method are overcome in the next method, which is called as ion exchange method or deionization method, which we are going to see in the next session. If you have any doubts in this session, you can simply put it in the comment box so that I can answer them. Thank you.